Hey guys, welcome back. Sorry that took a bit. Yeah, but I'm back now. So what I'm doing now is um, the uh, the debugging, right? So debugging, that means I have to check whether it's what the problem is for 3D elements. So that's what I'm doing. Um, yeah, wait a second. I'll still have to check my live stream if this is working. Yeah, should be working now. All right, so basically the first couple of things I want to do here is to make better outputs. So basically that can be a log file or that can be simply something which we would need for debugging purposes and stuff like that. Because for the 100 for the one for the 156K model, we still have a problem. But before doing that, let's just make a modified version of it. One that is not taking too much time, but has the same problem that the nodes would be disconnected here. Right, so this is what I would like to do. Alright, so let's just make this. Don't save, and let's load in the 3D model again. And then let's go again to the 3D split option. And let's just say I would like to split the elements around the center. Because that means we still should see the same bug, but yeah, not having too much time of waiting. Let's make that a little bit better. Because I'm a little bit afraid. I'm a little bit afraid that it will take too much time. So I think something like this should be enough. So we will split this and we will not adapt the connectivity, right? So the nodes and stuff like that, that should still be the same, but the connectivity will be broken at multiple points, right? And we will look at the graph and see what groups it will find. But basically the algorithm, what it should find is a group here and a group there. All right, so let's save that, or rather analyze that as a different model. Let's call that, let that be the mid model. Yeah. And by the way, if there's any questions which you would like to ask or something which you rather would see, not a problem. We can definitely do that. So today is just a chill stream, me implementing stuff, and yeah, so if I can talk a little bit about something else, I'm happy to do so. All right, so data model now has the mid, and the mid is now new, so I will copy that over again, right, into the input section, because that's where we are getting our models from. And this automatically did a copy, which is not what I wanted. All right, now it should be better. Now, first off, what should we do with the main thing? There's an output folder. So, but this is not belonging to any class, right? So this is not that out of a good thing. Let's make something here in this NPC force extractor, which is our main class, right? So we will make something like an output folder here. So this would be a string, and then let's do the following. When I'm creating this thing, I will also give in the output folder, right? So that's good. Then we have that. Add initialization. Let's maybe do something different here. So this is the output folder. How should we call that? This should be the same as the model name, I would say. And by the way, we are using the mid model here because that has the problem. So that's okay, that's fine. Now the output folder could be non-existent. It could be full of data. We have to make sure that it exists. So create output folder if it does not exist. Otherwise, delete the content. Yeah, so this is basically it. So if OS path exists, output folder, so if that folder does exist, I delete it, and else I will just do what? This is, yeah, okay, so I was missing something. So this is dealing with the output folder. Maybe that's also something which could be an own method that is not clustering it too much. Yeah, not sure. So, but this is now our output folder. And we will use this output folder to store data in it, right? This write summary method, where does it write to? File path out. So there's a file path out, and I think this is giving, yeah, we have the output folder. Hmm. I don't like that we have to give in something like this. This is a MPC force extractor, right? So we could just leave that away. Because why should we do that? Why should we giving a output folder here? So we can, because it's not a static method. So this file output could be, that should not exist. So we can delete that. Now we can delete that. Now the file path out. This is definitely something which we have to decide what it should be. Yeah. So I think that's okay. So file path out joins together the output folder and the summary.txt. So this is what we are gonna be looking at. Let's run it and see what it looks like, because I'm a big fan of just testing it early and see what we will be getting. So output, I will delete that. I should also delete the MPC forces summary. Yeah, let's delete that folder too. Let's now just run it. So basically what I think of getting would be something like that. Let's also do the start times again. Something like so. So we have that, then we have the building of for the rigid element. Yeah. Here we cannot do a start time because I think in the, oh no, we can do that. And now here we have to be a little bit more careful. The main thing is this method. There we have different sections. So print, calculating subgraph. Should we do that? Let's see. Let's see. Okay, something like this. Now we have a bit of info. Let's see. This model should not take too long. Mm-hmm. So merge the connected components takes a while. Interesting that it is that way. So something is off there. As I'm already assumed that this method could be done pretty much easier. Um, we have to maybe research if NX, so networks, if that offers us something. Um, how could we do that? Now, first of all, we now have some output here. It's not bad, but it's also not good. I don't think it's a good way of printing the seconds. So let's do that differently. So where was it? Here. So what could we do that? Is that possible? I'm just trying to getting it as 2-point float. No, that's not possible. Okay, now it seems to work better. Hopefully. Okay. Building the forces takes no time. Actually, why do I even put that out? Bildung. Another reason why to drop that. So in NPC tools, let's delete that. Yeah. Because that's not a problem. This is just taking one file. And this file, yeah, does just contain all the nodes of all the RBE elements. And so this is nothing, right? This is nothing. Okay, all right, we have that as an output. Now, the problem we can clearly see is with the merging, I would say. Merging the connected components. There seems to be something wrong. But either way, I would like to do a little bit of something to plot maybe the graph. That would be one thing. Maybe also to list the connected groups. That would be one thing. Yeah, let's start with connecting with listing the connected groups. I think the merging, as long as it takes, if it still does the job right, I would not bother too much for now. Graph visualization can come afterwards, but this merge thing, I'm really not sure why you would have such a problem. Yeah, okay, well, it's an n by n, but thinking of how many disconnected groups you have, it would be one per node, right? So because this is the absolute worst configuration possible, because every node has no connection to the next node, right? I'm sure there is a different way of getting the subgraph in such a way that connections which are spun over several vertices will be retained. But I didn't saw it on the first glimpse, so maybe we have to implement that by ourselves. Yeah. But the problem is this n by n. It still has a problem here with 17 seconds. Yeah, 17 seconds is for the whole part, but I would say maybe 5 seconds or so goes just for merging the components. And that means that the connected components are a large thing. Right? So let's check that. First of all, I want to write that into a file. I have no access to a self dot whatever output directory, which is a shame. Well, this returns it, right? So I might be able to get this. I would say this could be a variable, right? So let's just assume it would be it is a variable. Self part ID to slave node IDs. Why did I never use that? Did I just use it in the old method? I think so. No. No. Part IDs to node IDs is one thing. Yeah, so I have just this one. But then again, why do I call that differently? Huh? That doesn't make any sense. That doesn't make any sense. Maybe I named it differently. That's the same variable. That doesn't make any sense to do that. Yeah, we just make something like this. Then we can also skip that. Yeah, that has to be a self. Yeah, so this would be correct. Now, the only thing is that I would like to have this also being here. Wait a second before I do that. Let's see if we have that somewhere else. No. Alright, then this should be it. Okay, because if that's the case, I can use this. And the class NPC, I think, should be available from the main method, right? No. So where are this? The NPC element is definitely used here. Why can I not find it? At this, wait a second, I have to search for it. Where's the sum method? Yeah, here. So this is this. Maybe I should be a little bit more straightforward with my naming. So here it's called widget element in reader.widget elements. Let's rename that. Or should we rename it? Yeah, I think we should rename it. We should rename that. That's an NPC. For NPC in reader widget elements, I will keep it for now with the widget elements here. But then the NPC is no longer among us, but we have just NPCs. So, and let's also remove that and call it NPC2 forces. I think that makes more sense. Right? Okay, because now I can now write to the output directory from here. So I would say the connected group. Yeah. So this is a thing, right? Why is the type hint not working? So get connected components. That's definitely not right. What is there? We have that part ID to node IDs, right? So this would be, well, let's call it the same. Part ID to node IDs. Write it to the file. Okay, what do we have here now? So this is part ID to node IDs. Now we have a file path out is self output folder and then rigid element npc element ID dot text. Okay. We've opened that file as file write element ID. Yeah. Then master node is the master node coordinates. Yeah, we could do that. For element 1D in self element 1. Yeah, I think here it's rubbish. Was this all created? Yeah. No. What was created? So return NPC forces is the bottom point. Yeah. So we can delete all this. I think the master node ID makes sense. The coordinates make also sense. Now for node ID. No, not a node. File write. Yes. Slave nodes. That's right. And then write. So that makes sense. Parts. Yeah, this makes now more sense. For part ID and sorted part ID to node IDs keys. Yes, node IDs is that. File write part ID and then slave nodes. And then for node in node IDs. Not sure if I'm liking that. No, I don't like that. Let's come up with something our own. What should we do here now? Node IDs is what we should do. Let's join. Yes. Something like this. Yeah. Let's see if that gets us somewhere. What? F-string expecting. Don't we have that? Ah, joined. Okay. Something like this. Still a syntax error. So I'm missing a. I think this is not working. Yeah, something like this. And then just make this as a variable here. Okay, let's see what it comes up with. So basically, I would assume that I have now yeah, exactly. I have a folder here called Plate Simple Rigid 3D Mid. And now, when I come to here, it should put out something like this. Oh. NPC object has no attribute part ID to slave node IDs. Yes. Why did you assume it would have that? That doesn't make any sense. Ah, okay, sorry, that's the other one. That's the other one. We have to rename that to part ID. Come on, won't you help me? Something like this. Let's copy it. Let's be safe. Yeah, see. Let's search for slave nodes. Maybe I have... No. Okay, seems to work. So that was from the old output, the summary.txt. So this was still something I did not refactor. See, merge the connected components takes ages. Yeah, I'm not sure why. Okay, but we will see about this. So we now have this thing. Ah, okay. That makes no sense at all. That makes no sense at all. Not in the least. So I'm assuming that the Richards merge function is completely screwed. This thing here. I didn't like it anyway. So let's think about something better. Basically, let's maybe put that into a file just for us that we see something. Now, exactly at this point, we have not merged anything and we could write something. Oh, there's even a method we could. Let's see what it does. Let's see what it does, and then let's just return afterwards. Then we won't have too much of time to wait. It will fail, but we don't care. Just have to... Oh, sorry, I think I was just a bit too early with the return. Yes, return should be down here. We just want to have that file and see what it is. So I'm assuming there's a bunch of components, like maybe 100 or so. Oh, it's not a string. Yeah, okay. Do I have a possibility of giving string geyser? String geyser converts non-int, non-dict values into string. What is that, the string geyser? Let's see what we come up with. Not really, huh? Maybe. It should be a callable. That's a method, right? Yeah. Something like this. Yeah. That should be a method. It will call that and write then the output of this thing. Non-type object has no attribute. Yeah, that's a good thing. Now let's see. Do we have now this do we now have this thing here on the output? Yes, we have. It has an internal ID and then it has a bunch of nodes. But it has just nodes. Ah, okay. Okay, I see. I see. I think I know the problem. Hey, thanks, Crutch. Is that correct? Thanks for the best wishes. I know the problem. This is the worst configuration possible. Why? Because no node is connected to no node. So the subgraph has no edges at all. And well, to be honest, it's still not a problem for the algorithm if it worked correctly with the merging. But let's slow a bit down. Let's slow a bit down. So let's think about it again. First of all, what was the initial thing? So we had our NPC, and then we have our vertices, and we have other vertices. And at the top, I would make something like a normal way. So here, exactly what I want to focus on is this. This connection connects two of the slave nodes together directly. But what if you had something in between, right? Something like this. Then connections would look like so. And I'm not doing the cross references, so diagonal ones, they are not really giving us any benefit. But if I have something like this, think about the subgraph for the slave nodes. The subgraph for the slave nodes does exactly this. There's no connections, no edges, nothing. Okay, and then it begins merging. And it asks for those, as many as you have nodes, that's how many components you have. And it asks for this one, can I reach this one? Then I will merge it and have one. Yeah, so basically it should work, but it takes a bunch of time because that's just stupid to do it that way. You know what? We make it differently. We make it completely differently. So my idea would be the following. Let's just take care of this merging process. So this is screwed. So here I have now all slave nodes, right? Basically, that's just a complicated way of saying I want all slave nodes, right? Now the idea is the following. I would loop through this list once and just take the first one and see with one loop what can I add. Adding means, is there a path in the graph from one node to the other? That's far superior. So, okay. Let's say while all nodes from connected components has elements. No, it's not. That's nothing which we can use. While the length of all elements is bigger than 0. So let's hope that it figured out correctly what I wanted. No, it did not. Well, but so that's okay. This is the identifier. It creates an empty list there. For node in all nodes connected components, it appends it to the first list. Yeah, that makes sense. And then it does another for element in node connected elements. What? No, that's wrong. So it appends a new list, then it appends the node itself, and then it removes the node and puts it into a list. And now for connected component and connected components. So those are, again, this is a node, right? So this would be a node 2. If an X has path or something like that, has path, now I want a full graph, node 2. What is this? No. Connected components remove 2. No. I remove it here, but maybe that's not really... No, that's not possible. That's not possible because of a concurrent modification exception this would throw, because we're looping over this thing, so we cannot remove it while we're looping. So we're looping over all nodes, and then we're looping again over all nodes. Yeah. Now, if node and node 2 are the same thing, now if node equals node 2, then we would like to continue. So, and now if it has a path, then it will be appended, and this will not work. So I have to do something nodes to remove. Node 2. I would have to do that, and this should be new every time I have something like this. Because now I do that, and after a while I would remove those. It looks not too much easier than the code before, but I think runtime specific it will be a lot easier. Let's see. I have to think of this a little bit more. So while the length of all the nodes, so all the slave nodes, right? While this is bigger than 0, so that's still nodes have to be assigned to groups, right? This is exactly what it's saying here. Then I take initially a new list into part ID to node IDs, and the length of the part to node IDs plus 1 is the identifier. So that would be part 1. Let's make that more explicit because it's a hell of a lot to understand that. So this is the part ID. So part ID is assigned a new list. Nodes to remove is a new list. So for node in all the slave nodes, we can say that's a part ID. This makes it easier to understand. So I append this first node ID. The node ID, yeah, it has to be specific to node ID. And why is that, to be honest? Yeah, because this is what I would like to reduce. Yeah, okay, it makes sense. All right, so where are we? So I append the node ID to the list. That makes sense. And then this will not work, right? This will not work. But nodes to remove append node. Okay, now I'm looping over the second iterator. I'm still having mixed feelings about doing the n by n approach, but it should be good. It should be good. So for node 2 in all the slave nodes, if node equals node 2, that means I'm on the same node, then I just continue. And now I have two nodes. If I have a path between them, then I say I put that into the same list. Part ID to node IDs of the part ID, I append this node 2. And say node 2 can be removed too. So I'm doing that. So just think of it. I have one node. And then I'm looping through there. And whenever I find something which can have a path, then I will just add it here. And then I have half of the elements or half of the nodes assigned and removed from this. With the second loop, yeah, normally. So for first impression, I would say this works. Now let's see what this is. Yeah, we don't have to do this anymore because we have assigned the node IDs already, right? Okay, let's test it and see where it will fail. Because if that's working, that would be pretty epic, but I'm not hoping for it. Okay, it was quite a lot faster. So that's okay. And now let's do the following and see if the output is now better. No, it's not better. So basically it has merged all the nodes into one giant collector. Why is that? Why is that? Why is that? Ah, okay, I see a problem here. But even that should not be it. Let's try again. I'm not in any way capable of understanding now if that makes a difference. Normally I would say in the subgraph it can only have one part ID. That's correct, but it would not find the links to the others. So I would thought there would be a infinite loop, right? Because this will never be 0. And now it takes a lot longer, yeah, because again, now I have just moved the problem to the graph world, but I have still the problem that I'm now querying a huge graph, which I normally should not be doing. Yeah, this takes now ages. Man, that's not good. So querying has path is not a very efficient way of doing that. So maybe there's a better way of constructing the subgraph. That's maybe possible. But I will let this run through because I still have a little hope that it will at least output the correct result. But let's just think of it, the code before was with the subgraph. Why this takes ages. Maybe let's think about something different. How could we approach this differently? Let's think about it again. So this is the problem. We have the subgraph does not I mean, it's pretty odd. Yeah. To be honest, it's pretty odd that you have something like this. Normally, you would have a distribution overall. Let's just think of if 180 was that all the nodes? Yes. So 188 was all the nodes. And I'm really not aware of why this takes so long now. Let's try again. Maybe it was maybe a hiccup in the process. What's strange is that it worked for the subgraph for all nodes. That doesn't make any sense. Because the subgraph should not have the master node ID in it. So the master node would not be in there. So I could not... Huh. If it's working with the subgraph, I'm a little shocked that it is. Maybe we also should print the subgraph. So we did that already. So I think we can comment that out. Now let's write this thing just for us that we have it. There was something with a label, right? Oh no. What? Ah, it was pos. No, it wasn't. What do we have here? Pos is mapping none to none. Problem is I would like to have the node IDs here. Dictionary optional. Yeah. I don't know why this is. Something like this. And then plot save fig to data output subgraph. Yeah. Let's run it again. And let's just see how this is. But the subgraph. Too many indices for array. Huh? Those are the nodes and what? Wrong position of arguments, maybe? So graph should come first. Then wait a second, what it is? Pos, dictionary, optional. A dictionary with nodes as keys and positions as values. Oh, okay, I see. That's not a problem. That's not the one. Keywords. No. Come on, there must be a label or not. Huh? We did do that, didn't we? With labels, set true to draw labels, node list. Edge list, node size, node color, node shape, alpha. There's nothing in here. Style, labels. Yes, okay. So forget about this. Let's use a string layout, a spring layout, that makes sense. And let's use labels. Yes. Nodes, node ID for node and subgraph nodes. Yeah, that makes sense. Okay, let's run it. What do we get? What do we get? Yeah, nothing, right? Cannot see shit with that one. Do we have anything else? Yeah, those are the... It's pretty strange. To be honest, it's pretty strange. Normally, I would have guessed in the subgraph, there's not a way to get from one node to the other. So that this is true shocks me a little bit. Which one? This one. But in this case, I will just run it again and do a plot show. Because I would like to see that a little bit more for myself. Yeah, and we maybe have to also do something with an interaction or interactive things. So, okay, you see, what the hell is this? 27845. If that's the master node, I'm frustrated. But normally I would say this is just 2001. Okay, I don't see the 2001 here. But alright, now the node whatever to whatever, if this has a path. And this is true then? No, it's not true. It's not true. It's not true, not true, not true, not true, not true. Yeah, so that means nothing has a path. Ah, I see. And then... Yeah, okay, okay, that makes sense that this is not working. Okay, okay, this is not working. But then again, if I give in the complete graph, can we not do maybe a breadth first or depth first algorithm? Not sure. So there's plenty of tools to tackle this one. I'm sure we will be getting there. But for now, I will just see if why this is taking so long. Is it just because of the graph size? Maybe, I'm not sure. That can be. Now, one. Ah, you see, that works. You know what? I think the problem is that we created an infinity loop with the graph. What happens if a node, if there's just one node left? Then this will never be finished, right? Let's see if that's the case. Let's just print here the length of the all whatever, right? Because I'm guessing it will decrease rapidly and then be 1 1 1 1 1 1 1 1 1. Let's see. Let's see if that's the case. Let's make a thing here. I have to deactivate the plot show again. Oh, takes a while. That cannot be, right? I mean, you have a 1188 and 18088 here, so this is not a big problem. Somewhere, I don't know where, it must have a problem. Can I do now? Just... Okay, this is working. Let's make a counter and see how fast it is. They should be so fast. I mean, it has to count to 188. And plot show has to be deactivated. Where is it? Oh, it's not that fast. Okay, we have to think about something different. So this has path is a stupid way of doing what we want to do. Yeah, I think this has path will use some sort of depth of breast breath first algorithm. I think so. Well, how does it do? Shortest path. No way. No way. We have to think about something different. Search breath first for node 2 from node 1. Could we maybe say that we have a max iteration or something? Oh yeah, depth limit. So I would say this is a pretty fair statement. 10 layers of nodes should be enough. Okay, it should be enough to get the node. So if... Is that true? What does it return? What? I think I'm missing it. So this is basically... What does this do, actually? NX breath first. Successes. What does this return? Iterates over edges in the beam search. The beam search is generalized breath first, whatever. Yields edge. Edges in the beam searches starting from source, giving a pair of nodes. What does it do? What does it do if it's not working? Does it then return none? Hopefully, then I could use it like this. Let's see if that's any better. I think so. I think so. We see that with the counter again. Okay. Module networks has no attribute. Oh. Yeah, what's your final your project? Let's see. Maybe. Okay, 1, 2, and then module is not callable. Yeah, I figured that. Okay, so it's not that one, but we need something like edges. Something like this. Iterate over edges. Source, any, reverse, sort neighbors. No, that's not what we want. as a package, yeah. So what is it? Hmm. You know what? The easiest way would be if the has path would have a limit. Is there a limit? No. That's a pity. That's a pity. Maybe we have to maybe we have to do something prior to this. I'm not 100% sure if that method which I'm doing right now has the yeah, it has some perspective to success. Let's maybe figure out a way where we can deal with the problem from beforehand. So before going into the subgraph, could we make something that the subgraph could grow? Like it should just grow for, let's say, for 10 rounds or so. We already thought about this, and if you have two RBE elements which are close to each other, that might have some problem. Yeah, but actually no. Actually, that should not be a problem. That should not be a problem because we have the slave nodes and that's just one RBE element, so they should be separate. So I think this merging here is complete bollocks. I'm not sure if we have a option for success here. I mean, it will work, I think, eventually, but it will not run in time. So the timing here is just really off. Um, let's maybe fix the time. We could do something with a search method or something like a add some layers and then no. I think that's a harder problem yet right now. That's a harder problem because the connected groups, per definition, just have the slave nodes in it, and that makes sense. That makes total sense. So the merging, I think, is the correct position to do this. So WebEx edits, you think of what project exactly? That depends very much for what language you have to choose it from. Depends on what the constraints are. So if you want to do something with a server, it's maybe different than if it's something with a front end or something else. Yeah. So there's a problem. I'm not sure how to tackle this one. With the has path, it would be really not a bad idea. But the problem is that it is not working. What did I do what did I do before? I went over, yeah, it's more or less it's the same thing. I went over all the nodes and I went over all the nodes again. And this is the time complexity is just not good. So time complexity is an issue. But on the other hand, I'm not sure how to do this. This is all inefficient. It's all inefficient. Thinking about a salesman problem or something like a path problem where you say you start at one node of the connected components and then make your way through different nodes, that you just don't have this double loop. But that's still, if I'm trying to imagine how this would look like in a visualization thing, it would look like very computational inefficient or heavy work. What else could we do? What else could we do to do this? I think I have to step back a little bit mentally and see if I can figure out another way to tackle this problem. Because it's not a bad approach if it's fully connected. If it's not fully connected, we had a problem. Interestingly, it worked for the small groups, but now we have 180 groups, and suddenly it's just too much. I also cannot understand if it just has one giant connection here. That doesn't make any sense either. So I think I have to walk back a little bit and see if I can come up with something different. What could it be? So somehow the merging thing is the problem. But it's not a problem in terms of the algorithm itself. The problem is just that it's computational impossible to solve it in a good time. We could modify the graph by adding additional edges into it. So let's get rid of it. Let's get rid of it. So this doesn't work. This doesn't work at all. This merging thing, I'm not sure about it. So basically let's start over with this idea of the subgraph. I have the slave nodes. Maybe before I have the slave nodes, I could do something like, let's just specify a layer of maybe 2 to 3 times, and adding all the edges from elements to from nodes to nodes which are 1, 2, or 3 times away. I'm not sure if this works, and I would rather do it in the subgraph, but in the subgraph, I don't think I can do it. Can I? No, I cannot. Because if you just imagine back the subgraph, how it looked like, it was just a bunch of not connected nodes at all. Right? It was just a bunch of nodes which are not connected at all. Let's make a copy of the graph here. And let's say levels to increase connectivity. So Alex, can't you create a new layer and just add the forces that should add up to right forces? I'm not sure if I get this correctly. Do you mean that I just would change the connectivity? Or would I get from neighbor relationships something like this? The problem why I'm taking this thing is that I would like to have whatever model comes at this toolbox work correctly. And there could be the possibility that you have such a model. Maybe it doesn't make sense, but maybe just the user has something like this. And the algorithm right now cannot do that efficiently. That's why I'm working on this. And that's why I'm not changing the connectivity, because if I could change the connectivity, then the problem is solved. The problem is solved. Now, what I'm trying to do now is, normally you just have the connectivity between this and this and this and this and this and this. So just element wise. But if I would increase that to level 2 and 3, right, I will just add edges in the graph. Like, that means that I can go over the elements. Yeah, I'm not sure if that's a good idea. I'm not sure if that's a good idea. That could be a bad idea. That could be a bad idea, because if you would like to have some separation here, then yeah, you would get it connected anyway. So that could be not. Yeah, the thing is, if they stay separated, the output will be just really shitty. Because then you can really sum up. That's the problem. If you cannot sum up because you're missing the information, which part IDs you would like to sum up. The problem is you have as many parts as you have nodes, because no node is connected to any other node here. See? Problem is that you have 188 different parts. And that is not better than the initial output from HyperWorks itself. Then you can just use the MPC file. So the idea was now to maybe increase the level by 1 or level by 2. If you think about this, what this does, it just not connects the nodes directly, but the nodes one node further. And it just does this for the RBE nodes. That has to be clear too, right? It's just doing that for the RBE element nodes. Let's see if that works. If that works, then the connected components is that. And I think we now have to see what we did change here, because I think we changed a bit what we should have kept. So this was the initial thing here. That's the merging. That's the removal of empty things, and then we can maybe bring that back. Something like this. Let's see if that works. If that works, maybe we will keep it for now. And because it should not fail the other models, like the 2D model and stuff like that. That should not fail. But the output here should be now. Oh, okay. Now it's separated. So basically, I now suspect that we would have the 188 parts. Yeah, exactly. But the question now is that why? In this case, I would say this increase of the things here did not work. So the subgraph is still, cannot really see that. You cannot see that. Maybe this is... This is the nightmare of somebody who does programming courses, like for loops. Oh man. But the only thing, or the only reason I'm getting away with that is I know that the number of nodes is small. But just imagine how many neighbors we have. Maybe we have 30 neighbors. So 30 times 3 per node. So 180 times 30 times 3. It's not that small. But yeah. Yeah, but I'm not sure if that's correct. But at least we have now results here. And I think we had some similar stuff in Excel, if I'm remembering correctly. So if the summation here was correct. Oh, no, not really. But 1,400, that doesn't make any sense either. No, Alex, that's exactly the problem. Adding everything up will lead to 0. Adding everything will lead to 0 because you have the one side and the other side. And the one side is plus 500, the other side is minus 500. And that's the problem. Summing all is not gonna work. But there could be other means of doing the separation. So this is one just based on graphs and your element connectivity. Another option to just divide this into groups would be maybe the force vector. Can we treat this a new layer and derive final layer? How do you mean? So just think of it. You just have this data, right? So this is the MPC data. If you just sum everything up, it should be 0. If not, the model is has a problem. So if I sum every x component up, yeah, that's 0, basically, more or less. Why this is plus 3? Yeah, okay, this is our summation. Yeah. So that adds up to 0. Without a differentiation between parts, we cannot really accomplish anything here. But somehow I would also say that the 153K model has a problem. So I would have to maybe renumber that and just see. Because there's a problem, yeah. Yeah. You see it, right? So basically here at the top, at the yellow intersection, you have the 500 coming from here. And then at the blue, you have the minus 500 coming from there. And they both equal out to 0. That's a problem. And that's why we need a method for doing something like this. Yeah, maybe it's not the baddest idea to just do a direction thing, right? Here it's pretty easy. If you just see, there's no set direction really. But yeah, you could do something like phi theta and just calculate something like the cosine of x divided by y and stuff like that. So that could be it. Then so we have minus y values here, but yeah, not really. Yeah, you see plus, minus. No, I don't think you can do that really. The direction of the vectors. I mean, there's a lot of different possibilities. Another possibility would be the element centroid and just do something like a clustering approach. That would definitely also be suitable. If you just think about, you have all the nodes and you would do a 2D clustering approach. But how you know it's 2? How do you know it's not 3 or 4? You cannot really tell. So I think the element connectivity is still the best option. Yeah, you know what? For now, I will just leave that. I mean, that's pretty exhausting. And maybe we just have to acknowledge that for now, I cannot really have a solution for this. Let's see if the normal model works still with this code, because I think the code is slightly better. Yeah, but you have to know the number of parts beforehand. But the sum of absolute values divided by the number of parts is not bad if it's equally distributed. Yeah, that works. But how do you know that you have 2 parts and not 3? You're back at the element connectivity again. So this doesn't really... I mean, you can say you can see it here, but just imagine you have a model with 100 screws, and sometimes the screws or bolts are connecting 2 parts, sometimes they are connecting 3, sometimes 4. So you cannot do that. And basically, if you have multiple screws, you are screwed. Yeah, because you just assuming that this is working for one SPC or one MPC. One MPC it's working, right? But if you have 2, you would have to... Yeah, then it will not work at all. If you just do the number of NPCs you have, then you would get to the 250, but you would be wrong. Because it's not clear that they take both the same load. We have a model for that. I can show that in a minute. I think that's the rigid 2 model. Let me quickly load that model also here. So this has 3 separate NPCs. And if you look at the output, what the hell is this? Ah, wrong model. Yeah, you see, now we have 3 different RBEs. And in the summary, you see that you have different kind of forces. 250, 40, and 202. So basically you cannot say that you have, you cannot do it with the number of nodes. Or the number of forces, or the sum of absolute values. Yeah. I mean, it's a struggle, right? So it's all good. I mean, that's part of the process. So this is still working fine. That's good. So let's also check the rigid model, which should yield in 500 and minus 500. That we just see that this is still working. Yeah, I think timing is pretty good. Pam pam pam. Again here, the summary now with the rigid model summary. Yeah, that works. That works. And I think for the time being, I will leave it as it is right now. We can try and make a following adjustments to the mid model. Let's just use the mid FEM. Oh, I cannot do that. So reveal in File Explorer and drag that into the hypermesh again, because I wanted to just see if it's working for the 150K model if I adjust the connectivity, right? So this, if I just added this element and see the 188 nodes, let's just make it something that's pretty strange if you see it the first time, but you have to do it like this. And then update it again, that you can use the faces option. By face. Okay. Yeah, so you see mid is now correctly done, but now we have still one very strange node. Okay. So like this. And I will run this one again and see if we can come up with numbers which make sense now. So this is the mid model. Correct. Mid correct. So I will run it. Do not take that much of time. That's the good thing. The 1 million model I think we can throw away. That doesn't make any sense to do it right now. All right, FEM, MPC, SPC. Take that. Copy it into input. And then I think I have to change that. I have to change that model name. And then let's just do that makes more sense, right? So let's run this. Oh. How's it called? Rigid 3D. Hmm. Data input plate, simple, rigid, 3D, mid, correct. Ah, small m. So, is this an idealization of bolting? Yes, it is. So, bolts, screws, whatever, if you can say that it is just transferring the load in a rigid way, then this is exactly what this is doing. It's a very ideal form of it. The Rudman fasteners. No, I don't know that. Huh. Well, fasteners, I mean, I know the different kind of modeling techniques of how to do it. So for example, 3D with pretensions and stuff like that. Can do that also with 1D. You can also do that in Hypermesh. So maybe we'll look at that at a later point in time. There's some good tutorials out there already, so that's why I did not do too much about it. But so to applying 1D and 3D pretensions and stuff like that with contacts, and so that's definitely not a bad idea. Okay, now building the part ID to node IDs is taking much more time. You can already see that. Why? Because now we have 500 nodes. Maybe that's already a sign to look at the performance again. So somewhere here, this is maybe, yeah. As this didn't work anyway, let's remove this. because it didn't bring what we thought it would do. And therefore it just is unnecessary calculation time. And 500 nodes, and then you have a 3-staged for loop. That's not ideal. Okay, you see, that was faster. Now let's see if the result is of any validity. Wow, I cannot talk anymore. All right, so it was 3D mid correct. We have one thing here, and yeah, that's pretty interesting, right? You have 733 nodes, newtons in one direction, and the other one you have 124. I'm assuming this is correct. You have quite also a set component. So why could that be? If I look at the forces, right? So the lever arms and stuff like that, I think are something. But let's see that. I want to see that. Don't believe what you cannot understand. So normally you would think, well, it should have something of equal proportion. And the constraints are also on both sides. Well, this is not. Yeah, let's see it. So let's run that. That would be then the... Oh, where did I run that? Maybe here? No. Oh, by the way, it's the wrong program. Oh wow, wait a second, I have to search for the run. Okay, I think I got it. Should be that one, right? Okay, let's see at a vector plot. Vector plot of the NPC forces would be pretty interesting. Well, why isn't it there? Huh? So NPC forces, it's not there at all. Why? So this load step should have an output section. NPC forces. Ah yeah, I think it's because the opti. Yeah, okay, let's run it again. So multiple format export would be fine, I think. I'm not sure if that's an option which we can check that. Yeah, check with Excel. I think that is the problem why I'm trying to do it now with the visual thing here. I'm not sure if I got the element renumbering correctly that I see how to group them, because that's what I initially did, and I think it's not right. But I can do that. Let's just see that. So it would be this one. I'll just copy that. Because of the splitting, you know, because of the splitting, there's some things happening. So let's do that. Yeah, I think it's still valid what I had previously. So if now the same amount of forces comes as I have in my tool, then I would say this is correct. Oh, we have 733. Isn't that interesting? Isn't that what we had in the tool? But I think those... What is this? I think those have to be done too. Wait a second. What? Ah, sorry, yeah. Yeah, I think it's time for a break for me again. Okay, you see the second row or second nodes, those for sure are the middle nodes, they don't have any force. Yeah, so the sum of those two parts is then the 734 newtons, which should be, yeah, more or less that. Why isn't it exactly that? Maybe I have a, yeah, maybe that's because of the master node. That could be it. Because I did not delete the master node here. $734.29. Yes, it's different. So this group is correct. And this group begins with that ID and ends on that ID. So I think it would be correct too. Maybe there's a node missing still. Let's maybe count the number of nodes we have here. That's 47, and then we have again 47. So that's 94. And whew. There's much more elements here, right? So there's, I think, yeah. No, we cannot really tell that. There's more than that. So total is 580. So what I'm assuming is that you would have something like such a block again at a later point, something like here, going until, that's pretty hard to see. See that stupid element renumbering. You would have to renumber that in order to see it. But I think we can do it better or a little bit quicker if we just have it here in the H3D file and see for a vector plot. Oh, come on. Why isn't it there? That should be the newborn. Oh yeah, okay. So the first thing I would like to check is if it's unbalanced. Ooh, that's interesting. Okay. So you see, vector clustering would not be a thing. Not at all. Not at all. Okay, but now we can do a table and do the contour vector maybe even. And let's say nodes by, is there by phase? There isn't. Well, man, by window. Okay, now we have a lot of nodes here. Can export this temp table. What? Why? Okay, temp table.text. And if I just do that now and copy that values in Excel, we'll see what the sum will be for the upper one. So this should be the smaller number. But you see that would be the process of doing it by hand. So doing that. Oh, that's not even a number, so I cannot do that. I have to make it with comma. And then yeah, that's 500. Fuck. Somewhere this is wrong. That is wrong. Why the hell is this 500? And that doesn't seem to be like that in the window. Okay. What do we have here? We have 124. Maybe it's something with the resolved thing. Doesn't make any sense. Let's check that for the other one too. No, let's see. Let's see what we have here. Okay. That doesn't work. So we have to do that and open it first with a text editor. Split that by comma. Man, that cannot be. I mean, that's what I would have expected, right? That's what I would have expected. So to be fair, we did run it again, but we did not change anything, right? So I have no idea why this is not working. And this is a serious bug. This means it doesn't work like intended. So it has some... So I mean the 564 slave nodes and then the division between 2 times 282, that seems right. That seems right. Then we can speculate about this file here of whether those nodes are correct. Yeah, we can do that if we just copy this and make something like here, node by IDs. So this should be one side of the thing. Seems like it, right? So I would say it is correct in terms of the node ID. So this information should be correct. But why the hell then is the MPC force not correct? And something I don't want to complain about, but like this how this is shown here doesn't seem to me that it would be balanced, right? Well, but on the other hand, yes, we have something here, something there, and this could balance it out each other. So that makes sense, maybe. And from a statical point of perspective, it is what I would think of it. Now, but if that's the case, then we have a problem exactly at the summary, how those forces are calculated. So let's see where this is coming from. So the slave node information is correct. So rigid element, part ID to node ID, so this should be correct. But somehow the forces are not correct. There's some stupid mistake, 100%. Some forces by connected parts, node to forces. So we know that the slave nodes, those are correct. So part ID to node ID, this should be correct. Now part ID, node ID is in blah blah blah. Forces part ID is 0. And then for node ID, node IDs, if node ID not in node ID to force, then print something. And otherwise it sums it up. I mean, that was tested before, so that should not be the problem. Let's see. We can make something. Maybe we can make something. Let's rerun this. So basically what I'm now doing is I'm renumbering the elements in order for me to differentiate between them for the NPC forces. So first of all, what I should do is change the load step output again, that I have the files as opti. So what was that? The NPC forces, yes. Format should be opti. So I have a text file. Then I do the renumbering. And assembly renumber. So what should we renumber? We should renumber the nodes. Let's renumber those from 1 with step 1. Okay? And then let's renumber those well, I have to be very careful here. Those nodes as well. And let's start with 10k. Step 1. Right? So we can differentiate between them pretty good. I hope not. It's a garbage memory. Let's hope not. First of all, I want to check the NPC file. So I will run this one again as rigid 3D mid. No. Maybe I just didn't run it correctly. I hope that this is the case, and I will just run it again now with this model. And if it's now turning up correctly, it was just a file path issue. So this is mid correct. Okay, analyze this completely. I will now copy it in my file explorer. The FEM, the MPC, and the SPC forces. And copy that into data input. That it is replaced. Yes. Now I run it again. Before doing anything, I will run it again, check the model file. So model file is the rigid 3D mid correct, that's correct. Then we will run it, and if it's not correct, then I just did the run for the new run was done for a old file name, and then it's all good, hopefully. And if that's not the case, we will check the NPC file, because now we can. All right, where's the output? The output is here. Now we don't have anything. Come on. You must be kidding. What? I will delete this folder entirely and run it again. There must be something. Because that's something which... Oh, it really does not find anything here. Okay. Why is it like this? Let's look at the MPC file. So the MPC file looks suspicious. Why is there just nodes with 10k and more? And why isn't there anything below 10k? Huh? Did I just break the model? Yeah, as a text file, yes. The text file, yes. So can I just see a node here? What ID does it have? Oh, it has a much higher ID. What? I think we broke it. You know what? We will do the assembly renumber thing again. But now for just all nodes. Ah, yeah, okay, that makes totally sense. I thought I would have just 10k elements. That makes no sense at all. Okay, let's do that again. I will do here from 1 to whatever, right? So 43k was the highest number. Sorry. And now let's do from 100k. And maybe let's also include this one too, right? Okay, that makes sense. Now 20k. 120k is the maximum number of node IDs. All right, now let's analyze it again. And again with the correct file. This one. I'm pretty sure it was that we had just run it with a node file name, because you saw when I wanted to run it, it always pointed back to mid and not to mid correct. And so I think the mid correct was not actually run correctly, if that makes sense. But not sure, not 100% sure. That's why we're doing this. So time is 15:59. That doesn't make sense. It should be 16:03. What? I run it again. Yes, part 1 has more than 10k nodes. That was exactly the problem. It had around 20k. Okay, now models. Okay, that makes sense now. MPC forces, FEM and SPC forces being transferred to the input, replaced. And now let's just look at the MPC file just now. Okay, that makes no sense, right? So 10k. No, it doesn't. What the hell? Ah, sorry. This was the SPC forces. This is the MPC force, and that makes sense. Yeah. All right, that makes sense. Okay. Now, hopefully, it works now. Looks better, right? Now, let's see the summary. It should be in the mid correct folder. Yeah, now it works again. Man. Okay, all for nothing. No bug. It was just me sitting here and didn't click the right model with the output. So here it's perfectly fine. Yeah. And this was the 282 nodes, yeah. Yeah, that makes sense. That makes sense now. All right, I think I will call it a day. Um, for now. Maybe I'm back at the evening for another session, but I doubt it. To be honest, I doubt it. Yeah, it was fun. Let's quit and commit before we call it a day. So task lint. That's good. Task test. Should not be anything different because we did not change anything related to the test. Okay, that's good. So what actually did we change now? We have an output folder and print rules, and yeah, that's mainly it here. So I would say that's output, print, debug. And then for the widgets, what did we change here? That's refactoring. We remove the merging. Okay. Refactor, removed merging. So we will just require the user that the RBEs are somewhat good defined. Or we can just relate to the old method without a graph. I think the old method without a graph should work for those kind of things, no matter what. So we have now a slow approach, which definitely works, and a fast approach, which works for, I would say, 90 to 100% of the cases. I think that's okay. I think I could live with that. The next bigger test of that program would be to test it against a bigger model with lots of NPCs, like 100 NPCs and 2 million nodes or something like that. But this will take a lot more time than I could do it on stream. Maybe this will run in half an hour or so, something like that. I can test that maybe next week. Let's see about this. I'm not sure if I can, but if yes, then I would say that this could be a first alpha release also for testing purposes. Yeah. All right. Any questions left or something else we should discuss? I think I have a little bit of time. If that's not the case, then thank you very much for being here. It was a long stream today again. So I'm not used to streaming that long. Yeah, Alex, you have a question. Yeah, go ahead. For shell element, how do we get membrane stresses? Oh, I have no idea, to be honest. There is an option, I think, in the shell statement file where you can state that you have a membrane element, something which behaves like a membrane. I think you have to check that in the shell configuration, but it depends also which solver you're using. Otherwise, if you would just have to get some stresses from a shell element, there's well, I think what's still valid is the stress tensor, and then you have to get in with your normal direction vector of the plane, and then you get stresses in normal and tangential direction, and then you can do whatever you want with them. So I think that's definitely valid for the stress state for a shell element as well. But let me just quickly search that and see what I can make of it. Because I think I saw something about this earlier. Yeah, so basically you have bending stress, shear stress, and membrane stress. And yeah, so basically that's all tensor mathematics. Um, I would really, I would really suggest that you first of all do a little bit of ChatGPT, um, a little bit of a ChatGPT thing. So just me doing that, right? You see that I just asked how to get the membrane stress of a shell element, and you get some detailed explanation of how you do that. So membrane stress is something which you can get from the stress tensor, and yeah, so basically regarding hypermesh, you could export the stress tensors and then do whatever you want with them. But I think you can. There's even a better or easier way of doing it. This way would include, I think, changing the configuration of the element and just stating that it is a membrane element, and then it will behave, I think, a little bit differently, and you can get the stresses directly, and those are then membrane stresses, I think. If I'm remembering that correctly, I'm not 100% sure about that. But feel free to dig a little bit deeper into this topic. If I come up with something, I will definitely let you know. But I think that would be the best way forward. All right. Yeah. As I said, thank you very much for attending today, for contributing, for being here, for watching, for listening, for also commenting. Alex, you're a pretty good commentator here. I got a ton of value of your comments, and thank you very much for doing that. And yeah, I see you around maybe tomorrow, maybe today. Today, I don't think so, but tomorrow maybe. Yeah, and then we will be at the usual time again. So I think 10 p.m. or so in German time. 9 to 10 p.m. is the starting point, and then as long as I can keep my eyes open. So maybe 11 or 12. All right. Yeah. Yeah, sure. So, Alex, we can definitely talk about more about this topic of yours. That's definitely not a problem. All right. Thank you very much, guys, and I see you later. Bye, guys.